previous lecture, some student asked me why H plus is called as proton. So this is very simple. We know that the atomic number of hydrogen is 1 and the mass number is 1. So can you tell me how many protons are there in hydrogen? We have 1 proton. How many electrons are there in hydrogen? We have 1 electron. How many neutrons are there in hydrogen? We have 0 neutron. So if the hydrogen lose this electron, what is left? Left is only one proton. Therefore H plus is called as proton. So H plus, H lost his electron. So what is left? Only the proton. Okay, so today we are going to study the pH scale. So what is pH? pH scale. So what is pH? pH is the power of hydrogen ion. So pH is termed as power of hydrogen, or we can say potential of hydrogen. Actually this hydrogen here represents the potential of H plus ion. So pH, the formula for the pH is minus log to the base 10 of concentration of H plus ion. So this is the formula of the pH. If you have the molar concentration of H plus ion, you can just plug it into this formula, take the negative logarithm of it, and you will get the pH. Now can you tell me what is the unit of molar concentration? This square bracket represents molar concentration. So the unit of molar concentration is moles per dm cube, right? So the H plus ion concentration will be in mole per dm cube. You just plug it into this formula and you can calculate the pH. This formula can also be written as pH equals to minus log to the base 10 of H3O plus ion concentration. Why? Because H plus ion concentration is same as H3O plus ion concentration. Why it is like that? Because water can accept a proton and form H3O plus ion. This is my hydronium ion. Okay, so the concentration of H plus ion will be same as the concentration of H3O plus ion. So we can either put the H plus ion concentration here or H3O plus ion concentration. They both are same. So these two formulas are given in your data booklet. Okay. Now the other thing is that from this pH formula, pH is minus log to the base 10 of H plus ion concentration. I can take the minus sign on the left hand side, and then I can take the 10 to the power of both the sides. Then I will get 10 to the power minus pH equals to 10 to the power log to the base 10 of H plus ion concentration. Now we know that 10 to the power log to the base 10 of x is always x. Therefore 10 to the power minus pH will be equals to H plus ion concentration. So if pH is given to you, you can just plug in into this formula and you can find the molar concentration of H plus ion. Okay, so at 25 degrees Celsius, the pH scale, the pH value varies from 0 to 14. Okay, So suppose this is my pH scale and this is 0 and this is 14. So this is my pH scale at 25 degrees Celsius. This is very important. This pH scale holds good only at 25 degrees Celsius, and this is somewhere in between 0 and 14, 7, which is termed as neutral. So our water is neutral. If we go below 7, the solution become acidic, and if we go above 7, the solution becomes basic. Okay, so we can say that at pH equals to 7, we have a neutral solution, for example water, and at this stage our H plus ion concentration is equal to OH negative ion concentration. Okay, pH is 7 and our H plus ion concentration will be equal to OH negative ion concentration. So if we go less than 7, our H plus ion concentration increases. So we can say that at pH less than 7, so if we go below 7, we have an acidic solution, and our H plus ion concentration will be greater than OH negative ion concentration. We have more acid. Now if we go pH is greater than 7, pH is greater than 7 means basic solution, and at this stage our H plus ion concentration will be less than OH negative ion concentration. We have less H plus ion concentration when pH is greater than 7. So we saw, based on the concentration of H plus ion, our solution can be neutral, can be acidic, can be basic. Okay, so we studied that pH is given by this formula. pH is equals to negative log to the base 10 of H plus ion concentration. Okay, so if we plot H plus ion concentration with the pH, so suppose my y-axis is H plus ion concentration and my x-axis is pH, so this is going to be a logarithmic decay curve like this. So this is how the pH will change. So as the pH increases, the H plus ion concentration decreases. So here we can see as the pH is increasing, the H plus ion concentration is decreasing, and as the pH is decreasing, the H plus ion concentration is increasing. Okay, so now we will study the ionic product of water. So what is ionic product? Ionic product of water. So ionic product of water is given by Kw. Okay, ionic product of water. So we know that water dissociates into H plus ions and OH negative ions. We can write the equilibrium constant for this reaction as H plus ion concentration multiplied by OH minus ion concentration over concentration of water. Now we know that for pure liquids the molar concentration is 1, so we reduce this formula to H plus ion concentration multiplied by OH ion concentration. So the product of H plus ion and OH ion concentration is called the ionic product of water, Kw. So if we multiply the H plus ion concentration with OH negative ion concentration, we get the ionic product of water. And at 25 degrees Celsius, the value of Kw is 10 to the power minus 14. So what will be the unit of this Kw? Here we are multiplying H plus ion concentration with the OH negative ion concentration. So the unit will be mole square dm minus 6. Okay, so this is Kw is constant at 25 degrees Celsius and the value is 10 to the power minus 14. Now what will happen if we increase the temperature? If we increase the temperature, if the temperature increases, Kw value will increase. Why? Because the dissociation of water is an endothermic reaction. Endothermic reaction. What does endothermic reaction means? It means that this reaction requires heat, or it takes up heat to move forward. Okay, so if we increase the temperature means we are giving more heat to this reaction, so the reaction will move forward and we will have more H plus and OH negative ion concentration. And when we will have more H plus and OH negative ion concentration, then from this Kw equals to H plus ion concentration multiplied by OH negative ion concentration, this formula Kw value will increase. So you can see in the data booklet you have several Kw values at different temperatures, and from that table you can find that when the temperature is increased, Kw value increases. Okay, so we saw that Kw equals to H plus ion concentration multiplied by OH negative ion concentration. Now at pH equals to 7, pH equals to 7, it means our solution is neutral, and at this pH, H plus ion concentration is equals to OH negative ion concentration. And as we know that Kw is 10 to the power minus 14 mole square dm minus 6, therefore H plus ion concentration will be equal to 10 to the power minus 7 mole dm cube, and H plus and OH negative ion concentration will also be 10 to the power minus 7 mole dm cube. If you multiply 10 to the power minus 7 and with 10 to the power minus 7, you will get 10 to the power minus 14. Now at pH less than 7 means we have acidic solution, and in the acidic solution we know that H plus ion concentration is greater than OH negative ion concentration. Therefore we can say that now since Kw is constant at 25 degrees Celsius, at 25 degrees Celsius the value of Kw is 10 to the power minus 14. Therefore when pH is less than 7, that is H plus ion concentration is greater than OH negative ion concentration, we can say that H plus ion concentration will be more than 10 to the power minus 7 mole dm cube, and OH negative ion concentration will be less than 10 to the power minus 7 mole dm cube, right? Because the product of H plus ion and OH negative ion concentration should be 10 to the power minus 14. Now what will happen at pH greater than 7? So pH greater than 7 means we have a basic solution, and in that case our H plus ion concentration will be less than OH negative ion concentration. So we have more OH negative ions in the solution when the solution is basic, so it means that our H plus ion concentration will be less than 10 to the power minus 7 mole dm cube, and our OH negative ion concentration will be greater than 10 to the power minus 7 mole dm cube. Okay, so we observed an inverse relationship between H plus ion concentration and OH negative ion concentration, right? So we observed that when H plus ion concentration increase, OH negative ion concentration decrease, and when H plus ion concentration decrease, OH negative ion concentration increase. Okay, so when H plus ion concentration is higher than OH negative ion concentration, we have acidic solution, and when H plus ion concentration is less than OH negative ion concentration, we have basic solution, and when H plus ion concentration equals to OH negative ion concentration, we have neutral solution. Now we will study what are the differences between strong acid and weak acid. So strong acid and weak acid. So here are our strong acid and weak acid. So what's the difference between strong acid and weak acid? So the first point is that strong acid dissociates completely. Dissociates completely. Okay, while weak acid dissociates less than 5%. Example of a strong acid like HCl. So HCl will dissociate into H plus ion and Cl negative ion. Example of weak acid like acetic acid. There will be equilibrium between its ion and undissociated part. So dissociate into acetate ion and H plus ion. Third, so we mark a one directional arrow when we show the dissociation of a strong acid. So we mark one directional arrow, while when we show the dissociation of a weak acid we use equilibrium sign. Okay, because here our acetic acid being a weak acid is not completely dissociated into its ions. Now fourth point, how about the conductivity of strong acid? So conductivity of a strong acid is high because a strong acid completely dissociated into its ions. So we have high concentration of ions, therefore the conductivity increases, or we can say conductivity is high. For conductivity is high for strong acid, but for weak acid the conductivity is low. Conductivity is low. Why? Because our weak acid do not completely dissociate into ions, so we have low concentration of ions. Low concentration of ions. Therefore, conductivity is low. Conductivity is low. So, if I have if I use strong acid as an electrolyte, so the conductivity will be high and there will be more electrical current passing through strong acid, and the bulb in the circuit will glow bright because of more conductivity. Here the bulb will glow dim because of less conductivity. If we use weak acid as an electrolyte, the bulb will glow dim. Now, how about the heat of neutralization? So the heat of neutralization will be high when we use a strong acid. So we have high heat evolved during neutralization of strong acid, and the heat evolved in case of weak acid, heat evolved will be low in case of weak acid during neutralization. So neutralization means I'm talking about acid base neutralization to produce salt and water. During neutralization reaction, now what are the other differences? Other differences between strong and weak acid. Strong and weak acid. Strong acid, weak acid. What are the differences between strong and weak acid? Other differences will be rate of reaction, with the rates of reaction. So the rate of reaction will be high. Rate of reaction will be high in case of strong acid, while in case of weak acid the rate of reaction will be low. Okay, so I give you some examples of strong acid and weak acid that you must know. HCl, hydrochloric acid, is a strong acid. Hydrochloric acid is a strong acid. H2SO4 is a strong acid. This is sulfuric acid. HNO3 is a strong acid. This is called nitric acid. Examples of weak acid: acetic acid or ethanoic acid. Ethanoic acid. Ethanoic acid. Then HCN, hydrogen cyanide. Hydrogen cyanide. It is also weak acid. carbonic acid, H2CO3, carbonic acid, H3PO4, phosphoric acid, phosphoric acid. Okay, for the weak acid, the equilibrium is towards, suppose this is the dissociation of the weak acid, ethanoic acid, CH3CO negative and H plus ion. So the equilibrium is towards weaker conjugate. Okay, so this is my weak acid and this is its conjugate strong base. So the equilibrium is towards a weak acid. So always the equilibrium is towards a weak acid. Okay.